All right, ladies and gentlemen. So, first lesson of the year, simplifying rational expressions. Okay? So the word rational really means just fractions, and expressions means polynomial expressions. Okay? In other words, no equal signs on these problems. Okay? So the steps to simplifying rational expressions are these two here. And basically, we're just reducing fractions when we're simplifying rational expressions. Okay? Let's go ahead and look at this. Step 1, factor the numerator and denominator. So if possible, we're going to try to factor the numerator and denominator. It's not always going to be possible, but for our cases, it will be possible. Okay, all of the ones that we do will be possible. But in the event that it is not possible, then you just leave it as is. Okay. Step 2, divide out the common factors found in the numerator and denominator. So once we factor everything out, on the top and bottom, then we'll look for what they have in common on top and bottom, and then we'll cancel those out, or divide them out is the correct term. Okay, so let's go ahead and begin with the first one. We have a trinomial here. All these are going to be, well, on the first page will be trinomials. Okay, so let's go ahead and begin here. So we have a negative 20 and a negative 1. Okay, so we factor this off to the side here. Let's say we're looking for factors that multiply to make negative 20, so it's negative 4 times 5 or negative 5 times 4, right? Both of these will give us a negative 20, but we also need a negative 1. So which of these two would give me a negative 1 when I add them? Be that one right there, okay? So this one's going to be x minus 5 times x plus 4. Notice, negative 5 times positive 4 would give me a negative 20, and then when I add negative 5 and positive 4, I get a negative 1. Okay, now of course I could have done 10 times 2 a negative, or negative 2 times 10, but that would not have given me the negative 1 that I need in between. Okay, so that's why I didn't even write those. Okay, so once you factored it, basically you don't need that expression there. And then let's factor now the bottom one here, the denominator. So we have a 50 and then a negative 15. So I'll just do it off here to the side. So we have 50, that we need a positive 50 and negative 15. So that means I need to multiply two negatives together. So let's see, negative 25 times negative 2. That's not going to give me a negative 15. Okay, how about 10 and 5? Negative 10 and negative 5, that works. Notice here, negative 10 times negative 5 is positive 50, but when I add them, I get a negative 15. So that's what it's going to be. It's going to be x minus 10 times x minus 5. So here really is just another review on factoring. Okay? But now we're applying it to a fraction here. So notice here we have x minus 5 times x plus 4 in the numerator over, alright, this is still a fraction here, x minus 10 times x minus 5. Now notice, step 2 says divide out common factors. Now the common factors found here are the x minus 5. So we can go ahead and divide those out, or cancel them out, or cross them out. Okay, and whatever we're left with is our answer. So notice here we have x plus 4 over x minus 10. Now you may be thinking, oh look, x and x, they both have an x. Let's cancel those out, or cross those out. And the answer is you cannot do that, because these are not common factors. They're like terms. So x plus 4 and x minus 10, right? The x and the x are like terms, but you cannot cancel out like terms here when they're in fraction form, okay? So what we're going to do here is just leave it like this. That's our answer. Okay? Let's do another one. Once again, I have a trinomial and another trinomial underneath, so let's go ahead and factor. So here we have a negative 90, and then we need a negative 1. So I like to always start with 10 times 9, like 10 times a number if it ends in a 0. So I need a negative 1. So once again, I'm going to put the negative 10 here and the 9 there. So that will be x minus 10 times x plus 9. Notice here, negative 10 times 9 gives me the negative 90. And then the negative 10 plus 9 gives me the negative 1 in between that I need. Okay. Now let's do the 70. Notice it's a positive 70, but I need a negative 17 here. So again, I need to multiply two negatives together to get this result. Now, 70 is not a very common number that you use to multiply, but 10 times 7, again, it ends in a 0, so let's just try 10 times the 7 here. And so notice that'll give me the negative 17 that I want. So this will be x minus 10 times x minus 7. And notice we can go ahead and begin our dividing out now of the common factors. Okay, so here we have again the x minus 10 and the x minus 10. So let's go ahead and cancel those factors out. And so we're left with x plus 9 over x minus 7. And once again, you cannot cancel out the like terms. Okay, now by the way, I'm using cancel out, even though that's not what's happening. We're dividing out, but I think most students understand canceling out just means to cross them out. Okay, so that's my answer for this one. Next, we have x squared minus 9 in the numerator, and then x squared minus 8x plus 15. So we have a binomial and then a trinomial. Now, this numerator here, the x squared minus 9, should look familiar to you. Okay, this is a difference of squares. So difference of squares factor out nicely. It's x minus 3 times x plus 3. Okay, let's factor this one out here. We need 15, and then we need a negative 8 when we add. Okay, so since that's a positive and that's a negative, that means both of these need to be negatives here. So let's try this. Negative 3 times negative 5. And lo and behold, that gives us a negative 8 that we want. Okay, so this will be x minus 3 times x minus 5. Okay, now let's look for common factors in numerator and denominator. Notice it's just the x minus 3. And so divide those out or cancel those out or cross them out, whatever you want to call it. And then whatever is left that is not a common factor is your answer. So we have x plus 3 over x minus 5, and once again you cannot cross out those x's. They are like terms, not common factors. So that's my answer. Here we have a binomial and a monomial. Okay, so this means we cannot factor this out further. It's already factored out basically. I guess you could say 4 is 2 times 2 and x squared is x times x, but that's not really necessary. We could just leave it as a monomial. Now let's look at the numerator here. We have a 12 and an 84. Now does 84 divide by 12 evenly? Let's see here. Let's see. 84 divided by 12 is 7. So yes, we can factor out a 12 here. Okay. Now let's look at the variables here. We have x to the third and x squared. We always want to get the number of variables that they both have in common. So notice here, this one has 3 x's and this one has 2. So they both have at least 2 in common. So we're going to factor out a 12 and then x squared, okay? So think about this as an undistributive property, okay? So we're going to undistribute here. So 12x squared times what will give me 12x to the third? Well, notice we already have the 12. We already have 2 x's. We need one more x. So this will just be the x here. And then here we said, okay, 12 times what is 84? We said it's 7. We just did that on the calculator a moment ago, right? So 12 times 7 would give me the 84. And then notice I need x squared. Well, I already have the x squared. So I can just close the parentheses right after the 7, okay? I can just wipe this part out. And this is done with. Now notice here, I have an x plus 7 in parentheses. That's one of the factors, but I do not have an x plus 7 in the denominator. So that means I will not be canceling this x plus 7 out with anything else. So what's left to factor out is whatever I can factor from these two monomials. Notice that's a 12x squared and that's a 4x squared. Well, first things first, I can factor out the x squares. Both of those get canceled out. And then I'm left with 12 over 4. Well, we know that 12 is 4 times 3, so you could think of this as 4 times 3 right there, and just factor out the 4s, or cancel out the 4s there, so we're left with 3. So my final answer here is just the number 3. Okay? Alright, last one here. Once again, we have a monomial in the numerator, but then this time the binomial is in the denominator. So let's go ahead and factor out the denominator. Notice they both have 15, so that means I can factor out a 15. And then from the x powers here, we can factor out x to the third. And so that leaves us with, well, let's undistribute here. We need 15x to the third to multiply with something that give me 15x to the fourth. Well, it looks like I'm only missing an x, right? 15x to the third times x will give me 15x to the fourth. Minus 15x to the third times what will give me negative 15x to the third. Well, I already have the 15x to the third there, so I just need to put a 1 there. So this binomial, just factor that into this. And notice there is no x minus 1 factor in the top, so I cannot cancel out the x minus 1s. So that means that's going to be part of my answer. Oops, that just reminded me up here. I messed up here. Okay, so notice here, I have a 3, but then I also had the x plus 7. I just realized that I forgot that step up here. So that's why I'm going to fix this before I finish the other problem. So right here, we need to put x plus 7. Okay, so that's my final answer there. All right, so here we have now the 5x to the third and then the 15x to the third. Notice here I can factor out the x to the thirds. I can cancel those out, I mean. And then I have 5 and 15. Well, basically that goes away. And this here, I'm left with a 3 because 5 goes into 5 once, and then 5 goes into 15 3 times. So I'm left with 1 over 3 times x minus 1. Okay? And that's it. So now you guys are going to go ahead and try this on Delta Math. So make sure you watch the help videos there if you need extra help.